When working in 2 dimensions, we resolve forces in one convenient direction and one at right angles to it to easily determine unknown forces. Usually the directions are horizontal and vertical, but they can be in any direction. Let's consider 2 simple examples. Example 1. A weight on a string is suspended by 2 more strings as shown. Our job is to find the tensions in each of the 2 strings, T1 and T2. Firstly, the tension in the vertical string T must be equal to mg if we consider the forces on the mass. Now resolving forces about this point here, let's call it A. We resolve horizontally and find that T1 cos 30 is equal to T2 cos 45. And we can write that as T1 root 3 over 2 is equal to T2 times 1 over root 2. And that implies that T1 is equal to T2 times root 2 over root 3. Okay, resolving vertically now. We have T1 sine 30 plus T2 sine 45 is equal to T, which is mg. We can write that as T1 times a half plus T2 times 1 over root 2 is equal to mg. So we've got 2 expressions involving T1 and T2. We need to combine them to eliminate one to find the other. So let's put this one into that one and we get T2 root 2 over root 3 times by a half plus T2 times 1 over root 2 is equal to mg. We can simplify this and we end up with T2 is equal to root 6 mg over 1 plus root 3. And then finally we can substitute that back into here to get T1. So T1 is equal to root 6 mg over 1 plus root 3 times by root 2 over root 3, and that's equal to 2 mg over 1 plus root 3. Okay, let's do example 2. In example 2, let's consider this bridge, which is a framework of light rods forming equilateral triangles. Let's work out the forces on it. First, we'll assume that there's a weight acting on it in the middle, which is W, and it's supported at either end by forces from the riverbank on which it's standing. So these are reaction forces here and here, and they must be, because they balance this weight, W over 2 and W over 2. So those are our external forces, the weight and the reaction holding the bridge up. Now let's consider internal forces. So let's resolve forces at A. So there's this external force and there are these 2 internal forces from the rods forming the bridge. So at A, resolving horizontally, we have F2 is equal to F1 cos 60, because we've got equilateral triangles. So F2 is equal to a half F1. Resolving vertically, we have W over 2 is equal to F1 sine 60, which is equal to F1 times root 3 over 2. So that means that F1 is equal to W over root 3, and so F2 must be equal to W over 2 root 3. And we can continue doing this, working our way round the rest of the framework. So let's note here that the direction of these arrows tells us if each of these rods are in tension or compression. So because this arrow is pointing in this direction, it means that this rod is in compression. And because the arrow is pointing inwards here, it means that this rod is in tension. Let's consider the forces here. We have F1 again here, F2, F3 here, F4 here. And in a similar way, we'll find if we balance the forces at this point that F3 and F4 are also equal to F1, which is W over root 3. And then you can calculate the forces in the rest of this bridge.